Imagine you are standing in the middle of the most advanced laboratory on Earth. Screens everywhere. Data pouring in from telescopes a million miles away. Scientists hunched over keyboards, cross-referencing numbers they've checked 100 times. And the room is quiet. Not the quiet of concentration, the quiet of people who just realized something is very, very wrong. One of them looks up, turns to a colleague, and says 4 words that no physicist ever wants to say. The model doesn't work. Before you click away, subscribe to this channel and hit the bell, because what you're about to hear is not a theory. It's not speculation. It's happening right now, in real labs, with real data. And if you make it to the end, you will never look up at the night sky the same way again. For 30 years, humanity has operated with a quiet confidence about the universe. We had a model, a framework, a master equation that described everything: how the universe began, what it's made of, how it's expanding, and how it will end. Scientists called it the lambda cold dark matter model, the ΛCDM. And it worked. Beautifully, elegantly. It matched observations across billions of light-years of space and billions of years of time. Cosmologists trusted it the way you trust gravity, without thinking about it. But here's the problem. The model is breaking. Not at the edges. Not in some obscure corner of theoretical physics that doesn't affect anything real. It's breaking at the foundation. The 3 invisible pillars that hold the entire structure up, dark matter, dark energy, and black holes, are all being shaken at the same time. And the data doing the shaking is not old. It's coming in right now from the most powerful instruments humanity has ever built. 96% of the universe is made of things we cannot see, cannot touch, and cannot explain. We gave them names. Dark matter, dark energy, because naming something feels like understanding it. But we don't understand them. We never did. We just assumed they behaved the way our equations said they should. And for 30 years, the universe let us believe that. It just stopped. Let's start with dark energy. Because if you thought the universe was going to expand forever, slowly, gracefully, heat dying into a cold and empty void trillions of years from now, you need to hear this. For 2 decades, the story was settled. In 1998, scientists discovered that the universe wasn't just expanding, it was accelerating. Something was pushing space itself apart, faster and faster, like an invisible hand pressing against the walls of reality. They called it dark energy. They assigned it a value, the cosmological constant. Einstein had actually introduced it a century ago and then called it his greatest mistake. Turns out he was right the first time. Or so we thought. New data published in late 2025 changed everything. Researchers analyzed the universe's expansion using methods more precise than anything that existed in 1998. And they found something that made the room go quiet. There was no convincing evidence that the universe is still accelerating at all. The force that was supposed to be tearing the cosmos apart, the thing cosmology has been built around for a generation, may not be doing what we thought. But it gets worse. A physicist at Cornell went further. He took Einstein's original cosmological constant, fed it the new data, and ran the calculations. The result didn't just challenge the model, it reversed it. For 20 years, scientists believed the cosmological constant was positive, meaning the universe expands forever. The new data suggests it may be negative, which means the universe isn't flying apart into eternal cold darkness. It's going to collapse. A big crunch. Everything, every galaxy, every star, every atom falling back into a single point of infinite density. In roughly 20 billion years, the universe was never going to live forever. It's going to die the same way it was born, in a moment of incomprehensible violence. And this is where things change. Because this isn't just about the end of the universe. It's about the fact that we had it completely backwards. The entire cosmological story we told ourselves, the fate, the timeline, the destiny of everything, may be wrong. Not slightly wrong. Mirror image wrong. But that's not even the worst part. Point your attention now toward the James Webb Space Telescope, launched in 2021 at a cost of $10 billion, the most powerful eye humanity has ever pointed at the sky. Scientists expected it to confirm what we already knew, to fill in the details, sharpen the picture, color inside the lines. Instead, it looked at the early universe and found things that, by every law of physics we understand, should not be there. Galaxies. Massive, fully formed disk galaxies, the kind that are supposed to take billions of years to build, sitting in the universe when it was barely a few 100 million years old. Not one or two anomalies. Hundreds of them. Our models said the early universe was too chaotic, too violent, too full of collisions for delicate disk structures to survive. Webb found them 10 times more prevalent than any simulation predicted. Scientists named some of them. Blue monster galaxies. Little red dots. Objects so bright, so dense, so impossibly structured that the only way to explain them is to admit that something about the very physics of galaxy formation, something we thought we understood, is wrong. But here's the problem. It's not just the galaxies. Webb also found black holes at the dawn of time that are too large to exist. In our model, black holes grow slowly, feeding on gas and stars over billions of years. But these black holes are already enormous when the universe is barely a toddler. They didn't have time to grow that big. Not by any mechanism we know, not by any law of physics we've written down. They're just there. Massive, ancient, impossible, staring back at us through 13 billion years of time like a question we don't know how to ask. Every image Webb sends back is not a triumph. It's a warning. And this is where things get truly unsettling. Because hidden beneath all of this, beneath the dark energy crisis and the impossible galaxies, is a deeper question. One that physicists have been quietly terrified of for years. What if dark matter doesn't exist at all? Dark matter is the invisible scaffolding of the universe. It's the reason galaxies hold together instead of flying apart. It's in every simulation, every model, every textbook. We've never seen it, never detected it, never captured a single particle of it in any experiment, despite decades of trying. But we assumed it was there because the math demanded it. In 2025, scientists ran a new test, the Chandrasekhar dynamical friction test, designed specifically to detect the gravitational signature that dark matter halos made of particles would leave behind. They found nothing, not a weak signal, not an inconclusive result, a rigorous falsification. The kind of result that, in science, means the thing you were looking for is not there. Then, in 2026, galaxy clusters were studied under a competing model, one called MOND, Modified Newtonian Dynamics, that doesn't require dark matter particles at all. And the numbers matched. The mass was all there, in the visible matter, explained by a different theory of gravity. No invisible particles required. If dark matter isn't made of particles, then every simulation of cosmic structure ever run is wrong. Every model of how galaxies form is wrong. The scaffolding of the universe isn't what we thought. And the $300 million worth of underground detectors built to catch dark matter particles have been searching for something that may not exist. But it gets worse. Because while all of this is happening, the dark energy reversal, the impossible galaxies, the dark matter falsification, there is one more crisis sitting at the center of everything. The one that started this spiral. The one that refuses, no matter how hard scientists try, to go away. Two teams, independent, both Nobel caliber, both using completely different methods, both measuring the same universe, getting two different answers, not slightly different, different by an amount that is statistically impossible to explain as coincidence. The probability that this discrepancy is a measurement error? Less than 1 in 3 billion. One team measures the expansion of the universe using the early cosmos, the echo of the Big Bang, the ancient light of the cosmic microwave background. They get 67 kilometers per second per megaparsec. The other team measures it using nearby stars, supernovae, and distance ladders in the local universe. They get 73, a gap of 10%, more than 5 times the combined uncertainty of both measurements. And every new instrument, Webb, the dark energy spectroscopic instrument, has made the disagreement sharper, not smaller. The European Research Council is so alarmed they funded an entire project called Red H0T, specifically to challenge their own measurements. Scientists hired to find flaws in their own work, red teaming their own physics. When the scientific establishment pays people to prove themselves wrong, you are not watching normal science. You are watching a field in crisis. And this is where things change for all of us. Because here is what these 5 crises mean together. Not individually. Together. The thing the universe is made of, dark energy, may not behave the way we thought. The invisible skeleton holding galaxies together, dark matter, may not exist. The first galaxies broke the rules of formation. The universe's expansion rate contradicts itself. And the model designed to explain all of it is failing test after test after test. You are not watching the universe get more mysterious. You are watching the foundation of cosmology begin to crack. Slowly, silently. One impossible data point at a time. There have been moments like this before in physics, when Newton's equations couldn't explain the orbit of Mercury, when classical physics couldn't explain the glow of hot metal. Both times, what came next wasn't a fix. It was a revolution. Relativity, quantum mechanics, entire new languages for describing reality. We may be standing at the edge of the next one. And if we are, if the ΛCDM model falls, if dark matter turns out to be a phantom, if dark energy turns out to be something stranger and more violent than we imagined, then the universe that replaces our current picture will be something we cannot yet see. Something that may not have a place for our assumptions, our certainties, our comfort. The universe does not owe us an explanation. It does not owe us a model that makes sense. It has been operating according to its own rules for 13.8 billion years, and it has never once asked if we were keeping up. Maybe we never were. The real question isn't whether physics is breaking. The real question is what's on the other side of that break, and whether the universe we discover there is one we were ever meant to understand. If this made you feel something, that unease, that smallness, that strange hunger to know more, then you're in exactly the right place. Subscribe to this channel. Every video we make is designed to take you somewhere science textbooks were too afraid to go. Drop a comment below. Tell me, does it comfort you or terrify you that everything we know might be wrong? I read every single one. Like this video if the universe just got a little more frightening. And stay with us, because the next one goes even deeper. The universe is talking. We just have to be brave enough to listen.